Have you ever wondered what the difference between a data scientist, a data analyst, and a data engineer is? Well, today I'm going to wade through the depths of data to try to explain the key differences between these three positions. Let's start by breaking down the different roles these positions have. Have you ever worked with multiple CSV files and had to combine them into a single data set? It can be pretty tricky, right? Now imagine that, but instead of a couple of CSV files, thousands upon thousands of files, and they're all in different formats. How the hell do you make all those data sources combine into one usable source? Well, that's where a data engineer comes in. A data engineer is responsible for storing data, transporting data, and transforming data. They're often in charge of choosing how to store data as well. Should you store it in a data lake in an unstructured format, or in a data warehouse in a structured format? They're in charge of making these decisions and also optimizing their databases so that they work fast and efficiently. They're oftentimes charged with developing the architecture of their databases, deciding whether the data is going to come in through streaming or offline batches, and actually transforming this data for downstream purposes. So things like formatting strings, replacing missing values, and making sure that it's all in a usable format. An example of a data engineer's job would be wrangling data from multiple sources, such as images, CSV files, and an on-premise database, and then structuring that data and transferring it to a cloud application. Moving on, have you ever looked at a spreadsheet or a data source and wondered, what the hell does this even mean? Well, that's where a data analyst can come in to save the day. Fundamentally, I define a data analyst as someone who can sift through data, aggregate it, and then communicate the insights and values in a business perspective. In this way, they're combining technical skills with domain knowledge and business and communication skills. Oftentimes, these people are going to interact with the databases through structured query language, and then they're going to populate dashboards or visualizations from these and then interpret them. Fundamentally, they're taking the data and transforming it into the question, what does this mean for the business? What decisions can we make from these insights? But once you have all this data stored in a usable format, which is the job of the data engineer, what if you want to build a predictive model from this data? That's where a data scientist can come in. While the term data scientist encompasses a large variety of roles, I generally define it as someone who makes models, prepares data, and then evaluates these models. Data scientists also have a foundational knowledge in math and statistics and can apply these sorts of analyses where maybe a data engineer does not have this expertise. Oftentimes, the people building machine learning models and then evaluating these AI models are going to be the data scientists within any given company. So a data scientist is taking data from a database and feeding it into a machine learning algorithm that they may or may have not designed themselves. Of course, this is a simplification, but I like to break it down like this. Data starts off in data sources, which can be collected from images, video, or CSV files. This data needs to be stored and structured in a database. Once the data is in the database, it can be connected to a visualization software like Tableau to make dashboards and gain insights from it. Alternatively, it can be fed into a machine learning model which can make predictive evaluations from the data. Now, if you have a really good data analyst, they can communicate the insights from the Tableau visualization, and from there you can make business decisions. However, that's primarily based on past things. If you want to use your predictive model, then you can use the data from your machine learning model and make decisions regarding the future. In this way, all these concepts are intertwined, and the jobs of a data engineer, a data analyst, and a data scientist often overlap and are dependent on one another. Now let's talk about the difference between the skills of these three positions. So a data engineer needs to be well versed in lower level programming. It's going to be really helpful if they understand the fundamentals of coding and the inbuilt memory structures. That means knowing a bit of software engineering and not just fiddling around with Jupyter notebooks. Their technical skills also need to be diverse and spread across a large variety of domains because the data can be coming from multiple sources. Data engineers also need to be excellent planners. They're often in charge of managing databases and designing them, managing the architecture of a data source. Because of this, they need to be organized and make sure that they plan things well in advance so that they function correctly. A data analyst needs to have technical skills to interpret data, but more importantly, they need to have communication skills to communicate the value from this data. Data analysts also usually have domain knowledge. They have an area of expertise in a specific field, whether that be insurance or the medical industry. This knowledge helps them find patterns in the data and transform it into decisions for their business. Data scientists need to be excellent at defining open-ended problems and solutions to these problems. They're often in charge of defining what means success and developing their own metrics. They should also have statistics and math skills to be able to perform complex analyses on their data. Data scientists are usually also charged with improving models and finding ways to optimize procedures. And finally, let's break down some of the different technologies these three positions need to know in order to thrive. Because data engineers are going to be working with a lot of lower-level APIs, it's very important that they know a technology like Docker. And because they're dealing extensively with databases, knowing different database structures like Postgres or SQL Server can be very useful. Also, having a knowledge of the ETL pipeline process, or maybe using some cloud services like Amazon Web Services Glue, can be very useful to the job of a data engineer. A data analyst should be familiar with visualization tools like Power BI or Microsoft Tableau and be able to make dashboards from them. They should also have a foundational knowledge in SQL so they can get the data they need from the databases. Also, like I mentioned before, it's super important that they have strong presentation skills. So knowing presentation software like PowerPoint and Prezi can be very useful skills to have for a data analyst. And finally, a data scientist should be familiar with higher-end programming, such as Python. They should be experts in version control and have a foundational knowledge in tools like Git and GitHub. They should also have skills in visualization using libraries like Matplotlib, so you can see some of these skills and technologies do overlap between the three jobs, but they do have their own fundamental purposes. To oversimplify things, I like to think of a data engineer like a software engineer. They're in charge of the architecture and the processes that go into maintaining the data and the models. A data analyst is the communicator who's able to look at the data, come up with insights from it, and then transform it into business decisions. And a data scientist is someone who likes solving problems and using math, statistics, and programming, finding answers to those problems. The world of data can be very confusing and complex, and like I said, a lot of these roles and responsibilities overlap with one another, and the definitions are constantly changing and can be even different within any given company. But I hope this breakdown helped you gain a high-level understanding of the differences and similarities between these positions, and maybe will help inform you on which path you want to pursue when you're learning data. Thanks for watching, and I'll see you in the next one.